Good afternoon. Welcome to the Smart Grid Educational Series for September 2014. I'm your moderator, Erfan Ibrahim, and I'm pleased today to welcome Rolf Bienert, who will be presenting on the activities of the OpenADR Alliance, as well as the IP500 Alliance. And that will follow with a presentation by Phil Beecher. A lot of you know Phil Beecher in the industry, and I saw in the distribution list quite a few people who worked with Phil Beecher, so you are in very familiar territory today. And Phil is going to be talking about the activities of the YSUN Alliance. The purpose of these presentations, in addition to making you aware of the good work that's going on in these alliances, is also, as you are product vendors and you are people in utilities and integrators, start to think about how the work products from the alliance activities can help you in your respective business functions and technical functions. And then also see what kind of role you can play in these alliances, because these alliances are only as good as their membership and their participation. So the folks that are in these alliances are putting in a lot of their valuable time, and the rate at which we are going to adopt smart grid technologies really depends on how much consensus we have around the standards, around the business processes, and the policies that support both the technology and the business processes. So it is a consensus building effort. This is not where one smart guy comes up with something and says, this is the way we're going to do it, and everyone says, yes, we're going to do it. That's just not how it works. And you have to also balance two things. On the one hand, you want competitive advantage in the market if you're a vendor. And then on the other hand, you want to be part of something much bigger than yourself, so that the market can grow and consequently the revenue that you realize from that will grow. If you're a utility, your job is to make sure that electricity is delivered at an affordable price, in a safe manner, in a reliable manner. And having standards-based technology is a big facilitator in that direction. If you're a regulator, what's your job? Your job is to make sure that the consumer is protected, that their interest is kept. So the contention that often occurs between vendors and utilities, you want to reduce that contention by having the proper regulatory framework. Again, having standards, building consensus around those standards is very important. And if you're an integrator, this is a must-have, because you can't really come and claim at a customer site that you can solve their problem and you can integrate the infrastructure if you don't know what the building blocks are, if you don't know what the interfaces are in which this information is exchanged. So as I see it, these alliances are like the building blocks of the industry. Now, you could have many different technologies, but adherence to those standards and having these alliances help accelerate the process of building those standards, which then get approved by IEEE, IEC, and other standards bodies, is a big part of that overall process. So when we started this whole smart grid effort about 5 years ago, I remember in Washington, D.C., when George Arnold stood up and said, we have to do everything, but we have to do it 5 times faster than how it normally happens. These organizations are those accelerators. So I'm really, really pleased to have both of these gentlemen here today talking about these 3 very important alliances. At this time, what I'm going to do is I'm going to share our desktop so that I can go to our first presentation. And the first presentation is on OpenADR, and I'm going to go into our full mode. There we go. And then what I'm going to do is I'm going to ask the folks who are online if you can see the slide. Now that I have shared the desktop, if you could put in the chat window and just confirm with me that you're seeing the OpenADR presentation, the first slide. Okay, very good. So now I will welcome Rolf, who will introduce himself and then also talk about OpenADR. Rolf?
All right, thank you. Excellent. So this microphone works for the
Yes.
WebEx as
And
well?
if you like, I can change the slide if you want to do it yourself. It's up to you.
Work?
Yeah. I'm just going to put this here in this corner.
You probably have to activate the slide itself.
Let's bring it down here, yeah. Okay, very good.
You got to click on the slide, it's not forward.
Okay.
Click on the slide
Yeah.
once. Yeah. Is that the receiver?
Oh, yeah, that might be it.
There we go. Works.
All right.
Perfect.
Welcome, Rolf.
Right. Thank you, Erfan. Well, thanks everybody for coming here today. See a lot of familiar faces, of course. So good to see everybody again. Many of you know OpenADR already. Maybe for the audience here in the room, obviously we cannot do it on the webinar, but quick show of hands, who has never heard of OpenADR? Okay, very good. We have a few. So very good. So what I'll do is I'll introduce the Alliance very briefly, introduce OpenADR in general, conceptually very briefly, and then I'll tell you a little more about what's going on this year and next year within the group. Obviously, we have a lot of milestones that we passed, and now we're going into the implementation phase of things. So a lot of things happening there. So in a nutshell, again, a lot of you know that, but OpenADR is a communication protocol between the utility or a demand response program operator and a facility. Essentially, a web services system that creates event messages, pricing information, things like that, that are being sent through the secure internet down to facilities. These facilities can be aggregators. You see here those online on the right-hand side of this picture, aggregated loads, companies that essentially are the middleman between utilities and bigger or smaller resources out there. Or it can go directly to buildings, to facilities, large or small. Either one works here. So a quick timeline on this. A lot of you are certainly either from California or have lived here since quite a while. I always say, well, back then when I arrived in California in 2000, I was here about a year and we had blackouts. So I was pretty bummed coming from Germany and then coming to the Silicon Valley and have blackouts. That was kind of weird. But what I learned way later was that obviously the California Energy Commission also didn't quite like that. So they formed this program together with the LBNL group, the Lawrence Berkeley National Labs, and some companies to define a technology that could help eliminate these outages. Basically, controlling the demand side of things. At that point, you can imagine it was still pretty new, so the smart grid talks just started just before that. So they worked on this for quite a few years, between 2002 and 2006, until OpenADR 1.0, a slightly more limited version of OpenADR, was brought out by the lab. It's an open spec. It's available on their website. You can download it. That's where the name OpenADR came from. It was an open project there. But there are only a small number of vendors that tried to be interoperable, and there was no interoperability program, no certification, no testing in particular. But the client vendors would just go to the server vendor and try to do their thing with them and determine if it worked. So after that, and after the whole NIST smart grid initiatives that you all know, SGIP, UCA, and so on, took a hold of the smart grid development, the key stakeholders decided around 2009, 2010, it would make sense to take OpenADR 1.0 to the next level. So OpenADR 1.0, as well as other requirements from NESB, from PERC, from other organizations, were taken in. And I think there's a question about the screen size here. like there's an overlap there on the slide.
Yes, I'm going to move the camera to the other side.
Well, the camera, and I think that the chat.
Oh, the chat window, yeah.
As well.
Okay.
Yeah.
Sure.
Either way, we won't be able to answer anyways.
Yeah, I'll go ahead and minimize this now, and then take it.
Like that.
Yeah.
So the OpenADR Alliance was then eventually founded in 2011 or late 2010. And we started working on this output from the Smart Grid Interoperability Panel. They worked with another group, the OASIS Open group out there, to create the framework for all of this, the energy interoperation. And obviously you don't need to know all of this, just a little bit of a background here. And based on that, OpenADR 2.0 was born. Right? So we profiled the energy interoperation and came up with two profiles, OpenADR 2.0A and B. We created testing certification, we went through IEC and so on, and we'll see much more of that on the following slides. There we go. So in short, the mission of the Alliance is to foster the global development, really to bring open automated demand response out there, to have certification and testing, to have education, and to really collaborate with any of the groups out there. For instance, also YSUN and so on. So that was the main goal of the Alliance here. We have now about 100 or close to 120 members. This is only one snapshot of the member logos here, and we really try to work closely with SGIP. We're one of the ITCAs that the SGIP identified, which is an organization that essentially manages an interoperability certification and testing program. So we followed all of their guidelines to do that, and so on and so forth. So a quick chart on the last 4 years, how the membership grew. You see the total members have gone up quite significantly here. What's also interesting is that what originally started as a very US-centric, or even, you could even argue that it was very California-centric in the beginning, but those days are long gone now. As you can see, there are a lot of international members joining. This is probably even outdated, it's a couple of months old, so we keep seeing more people from Europe and Asia joining. And I have some interesting update slides also on Korea and Japan later in the presentation. So not only have we, in the US, gone way past California, but also globally, we have got a good footprint now. All right, now let's review this a little more in detail now. So there are these key terminologies that you definitely want to keep in mind when you talk about OpenADR, or if somebody's talking about OpenADR. It's essentially a server-client model. It's always peer-to-peer communications. So we are not doing mesh networking or things like that. That's for the mesh network technologies to do. That's for other computer networks to do. We always talk from one server, either on the utility or ISO side or on the aggregator side, to one specific client. Now, don't get me wrong. Of course, you can communicate with thousands or hundred thousands or millions of clients, no question about it. But again, each and every communication is individual, just like when you log in with your computer to your bank, or you log in with your Facebook account, it's an individual communication channel there. So we have what we call the VTN, the virtual top node, or essentially the demand response server that always sits on top of the chain, and it sends its events down either to like a residential VEN, the virtual end node or client, or of course commercial, industrial, small, medium businesses, or as you can see here on the left-hand side of this picture, it could send an event down to an aggregator that functions as the virtual end node on its top connection, if you will, and it acts as a virtual top node, again, like a server, to its own resources. So Again, I want to make sure everybody understands that a message that comes from, in this picture here, from the ISO or utility going to the aggregator and continuing on, say, to this residential unit down there, this is not the same message. So the message is not just passed through here. The OpenADR message terminates within the aggregator. The aggregator does its thing with it. They might have certain logic, they might have different programs for different participants, and they decide who they engage on the resource end, and they will create a new message down to their resources. So again, we're not doing meshing here. I like to emphasize that because we always get questions about security, and this is one of the key aspects to our security mechanisms, is that we really only talk peer-to-peer here, server to client, and not meshing it up. All right, just a slightly different depiction here. So the OpenADR service provider can, of course, talk through the internet directly to an ESI, and to any kind of energy management system in the home area network, in building management, in factory management. And as we try to show here, it can be any kind of technology on the other side. We can have Wi-Fi connection, SEP, Econet, any kind of communication within the building. This is completely detached from OpenADR. We provide the information so the building can make smart choices about the energy usage at a certain point in time. Same applies, of course, since we have done here, just looked at you here. Same applies, of course, for inverters, for instance. So you could send the same type of information down to inverters or to microgrids. Doesn't really matter who receives the information. It's about energy. It's about how much energy you can either save or reclaim to the grid, and about price. That's really the key elements. And of course, they come in all different shapes and forms, but that's fine. OpenADR can provide that information down to the systems. And then, for instance, SunSpec can do their thing, get their reports, do their controls. All right, I mentioned briefly that we have two profiles, the A and B profile, and just to kind of give you an idea again, we have this framework of energy into operation 1.0. And if somebody is interested in reading a huge document or downloading big schemas, you can just Google energy into operation on Oasis, and you can download it there. It's the framework for it. And we took parts of it that we used for the A profile, which for us is a simple starting point for OpenADR. It was imagined to be for simple devices, small energy management systems, even alerting systems to an extent could use it, thermostats, things like that don't have the computing power than bigger building management systems would have. Essentially, it only has what we call the event service. So we will only be able to receive events that have simple levels that tell them, okay, we have a level 1, 2, 3, 4, which could be 1, normal operation, 2, either the price goes up, or please shed some load, 3 would be high shed or higher price, for instance, and a level 4 could, for instance, be used as an emergency signal, or like extremely high price at this point in time. I'm saying it that way because that's exactly how California utilities have started with that. Normal, moderate shed, high shed, and emergency. Emergency meaning you should give us as much power back as you can, otherwise you might face outages. But I also know that some areas use this as a communication interface. So they give you like an alert level, right? Where 0 is the network, the grid is stable. 1, it gets a little touchy on the grid. 3 and 4, very high likelihoods for blackouts, for instance. So there could be all kinds of messages conveyed in there. Then for the B profile, this event messaging service became much, much bigger. So now you can address specific systems, you can address temperature offsets, you can address exact numbers of curtailment that you're looking for, any type of pricing. You can send baselines, very flexible baselines throughout the day, throughout the week, whatever you like. The options are very big. And if any of you has looked at the schema, you'll notice that we use WX Calendar for these functions. which is a spec coming out of Oasis, where your Outlook uses a similar, if not the same format to send calendar notices. So obviously there's a lot of information in there, and we use some, maybe not all of this functionality. Then we added some additional functions, opt schedules, where resources can basically provide you with a schedule of their availability. This could go pretty far ahead, of course, reporting, where you get either historical data back, instant telemetry feedback, or even predictions or forecast models, and so on and so forth. And a register party, which has a misspelling here, that connects the devices on just a connectivity level. So all of this is just parts of this energy interoperation spec. So since we wanted to build, of course, a technology that manufacturers can take and implement, we had to go back and add a lot of things to what we found in energy interoperation. Energy interoperation is the data model. They show you how to send information, but they don't tell you how the devices should connect, what they should do for interoperability and things like that. So we started working on transport models and transport protocols. First, it was pretty convenient. We took simple HTTP, kind of slightly modified REST interface, or I should say reduced REST interface. And then we were looking for a transport protocol that gives us a very fast connection to customers, and at the same time is very robust and has been proven in the market. And we looked at a lot of them. We looked at probably like 60 of them, and all of them, including XMPP, I should say, have their advantages and disadvantages, no question about it. But we eventually chose XMPP because it is already being used in a lot of systems out there. If you open your Facebook account online, that status bar that pushes notifications to you via XMPP. There's a lot of instant messengers that use XMPP. So we liked that aspect of it. So we implemented XMPP because we wanted to really have a solid and reliable way to convey the demand response messages very, very fast to the resources. I'm not a substation expert, but I know that a lot of the response times in there are 4 seconds. So that was one of our goals, to be able to convey a signal reliably within 4 seconds and get a response from the resources. Again, I want to caution you, that doesn't mean that the resource is able to shed load within these 4 seconds. I mean, that's a different story. Even if you turn off your air conditioning, it will still run for a little while, for a few seconds. Or if you want to throttle down a machine or even dim light, it will take a few seconds for signals being propagated and so on and so forth. But getting the information there in that time frame was important to us, and the resources can act accordingly. On the security side, we have 2 levels. The standard security, which uses TLS connection with server and client certificates. Having these client certificates is still fairly new for manufacturers, and quite frankly, it gives them some headaches, but it is really the only way to be compliant to the latest and greatest security requirements. And we have then also a high security level, which adds essentially digital signatures to the messages themselves. This is really, if you want more non-repudiation, so if you want to really prove that you did send a particular message and that the receiver has confirmed that particular message, then you would use something like this. We think that in particular, when it comes to high energy negotiations, ISO to utility, things like that, when they talk about gigawatts, then it will be really important that they can prove, even in a court of law, that the other end got that right message. All right. So I already mentioned these services, so I can be quick on this. The clock here inside. And essentially, the only thing I didn't mention yet, these are all XML payloads, so fairly easy to parse and fairly easy to implement. So the Alliance went then ahead, actually, in fact, from the very beginning, and set up the certification and testing program. We really wanted to try to avoid making any mistakes on that end and be as interoperable as possible. A lot of you that come from testing, they will know that 100% interoperability is almost not achievable. You would have to do so much testing, it just doesn't make sense. But we want to get it to a really high level, the highest possible level of interoperability. So we create these profiles, and we create a lot of conformance statements in these profiles. The B profile, for instance, has more than 500, although there are some gaps in there. So certainly way more than 200 conformance statements that tell the manufacturer exactly how to implement the different features, parameters, and so on. And then we create a PICS document, a protocol implementation conformance statement. We have test plans. We have a certification test tool that the Alliance owns. We built that together with Quality Logic. Basically, our members can purchase that if they want to for their pre-testing. It's exactly the same as the test lab is using. And of course, we have a number of other certification documents that we use. So we are at about 58 products that are certified. These are just a few examples of them with some well-known names here. Yeah, I was right, 58 products that we have currently certified. So we are very happy with that because we are not in the consumer space per se. So not a lot of these products are necessarily consumer products, even though we do start to see more thermostats and things like that popping up. All right, then now a little more an update here of what's going on. So a lot of groups, in fact, 2 IEC working groups approached the Alliance. One was the IEC PC, the Project Committee 118, and they are looking at connectivity between the grid and facilities, just like TC57 here in the second line, with a similar yet a slightly different charter. They both approached us, and we have a liaison with them in place to work collectively on their standards as well, and their integration of OpenADR in their standard framework. So I'll show you that standard. So the 62, the IEC 62746, here the edition 1, which is currently in, I should say, production, if you will, at the IEC, has now OpenADR in there. As you can see here, -10-1 is the PAS, the publicly available specification. It's the OpenADR 2.0b profile specification, essentially taken. They slapped an IEC header on it, and they published it as one of their publicly available specifications. So we're reasonably happy with that. And so they basically put it in their main framework here, and they are now working on a lot of these other items. So they're still working on the architecture. I think they expect this to take another 5 years or so for this framework to be complete here. Then Korea, in fact, approached us last year. Korea has been a little, I shouldn't say behind, is probably the wrong word, but they've been a bit careful with evaluating the technologies. But the Korean Smart Grid Association has now really taken a liking of OpenADR, and we are in fact in the process. I think they're scheduled to sign our agreement next month, mid of October, to become the OpenADR Alliance Korea affiliate, basically. So going really well there. We're looking at some test events coming up there, some seminars. So we're seeing more members from Korea joining through that. Japan, for those of you not familiar with it, in fact has very much made OpenADR their standard of choice when it comes to the demand response communication. They have, of course, other standards as well, like Econet for the buildings, YSUN for the neighborhood area connectivity, and so on. But we are very happy with the way the Waseda University in Japan, with their members, has approached this, and they have a lot of trials running. They were, in fact, the first, I think, one of the first groups that, in fact, tested the OpenADR 2.0b specification with all their services successfully a few months ago. So they have these demo facilities in the Bazaar universities, essentially 3 homes, not even 4, that have different home area network technology in there, from Econet to SEP1 and so on and so forth. And on the other side of this here, they have a big control room that simulates a utility head end and provides information via OpenADR to these facilities here. So very good progress there. All right, just kind of an eye chart here, but you can read that later. Jumping back to California, a lot of you might be familiar with Title 24, the building code. So it was recently changed, and as of July 1st of this year, any new commercial building over 10,000 square feet or any major retrofit now needs to have a standards-based demand response interface built in. So that could mean anything, of course. Any standard that would fit could be used. Well, the good thing for us, having my OpenADR hat on, is that pretty much all the utilities in California only use OpenADR. So by extension, that means that these commercial facilities will need to have an OpenADR interface. And the same is true for other systems out there that will come to, these regulations will come to bear sometime soon, for instance, for billboards, big billboards. I recently learned that they use a lot of power, and they want to restrict that. Then we'll quick review then. I mentioned already a lot of these things. So last year, I think, I don't know, Erfan, when we had the last information seminar on this, maybe a year ago. Yeah. So we finished the 2.0b spec, started all these discussions with Korea, Japan. We have now, we have over 4,000 downloads of the spec. And then we started working on our implementation guidelines. And I'll just spend a few more minutes before we close on this in a few slides here. And one thing I wanted to mention, however, from this slide here is that EPRI has been working on an open source software stack that implements OpenADR. And we have all here from EPRI, so if anybody has interest in that, I'm sure Rolf can give you all the information on that. So they're going through testing right now, or are even done already. So it's going to be a certified open source software for servers and clients being available. So we're looking forward to having that. And last but not least, from this slide, we also started now working more closely with Europe. We formed a European interest group with the objective to really understand the use cases in Europe. They're slightly different than they're here. A lot of it has to do with the solar, for instance, that's being installed in Germany. They actually have too much power, not too little, like many states here. And so they need to figure out how the use cases work with OpenADR there. You kicked me out again. You got to click on the slide so I can progress.
Oh, yeah, sorry.
All right, so how much time? A few minutes. So wanted to show you what our next plans are. And as I already said, so right now, OpenADR defines the interface. Just the interface level. We give you a lot of different options, a lot of different parameters and features that you can use. But we do not necessarily define, of course, the content of these parameters. That depends on the demand response program, what you want to achieve. If you want to do real-time pricing, if you want to do some baseline, critical peak pricing, things like that. You can do all of this, but we do not define it on purpose. We didn't want to define it because the utilities have so many different ways of communicating the information that we didn't want to restrict that. However, a lot of the utilities, as well as the implementers, came back to us and said, okay, we have never touched demand response. We want to get into demand response. But we understand what OpenADR does, what SEP does, what other standards do, but where do we go from there? How do we implement that, and why? That's why we started working on the implementation side of things. So the specification, I want to make sure you understand, is complete. The specifications are going to change, but we are now working on a second kind of publication that will define specific demand response programs. So if a utility, for instance, has a certain objective for their program, has certain goals, what they want to achieve with the program, they can walk through a decision tree that we have in our implementation guide, or will have in our implementation guidelines, and can arrive at, say, 2 or 3 very specifically defined demand response programs and how they are being implemented with OpenADR. This gives the utilities a good starting point, what to look for, how the devices should function. That's, again, behind the OpenADR interface. It also gives the vendors a good idea what to build. Not only, again, on the OpenADR communication interface, that stays the same, but behind that, in their management systems, in their building automation systems, in their thermostats maybe, they can better understand what functionality is needed and what they can build into that. So we want to really create these DR program templates that are eventually testable, so that a manufacturer of a thermostat, again, or a building automation system can, in fact, qualify themselves to certain demand response programs out there, which goes a little bit beyond the scope of OpenADR initially. So just to give you an idea, decision tree, you have, for instance, liability and safety. You have many different ways of looking at this on a secondary objectives perspective. And then, of course, you have certain load profiles that you can address. And then it goes down to the different interaction patterns. So you can review that if you want, and also our list of other primary and secondary objectives that we started for the utilities, and want to give that to them as the decision tree here. All right, that's what we do right now. We are looking for information from utilities. We have already collected a good number of them. We have now, I think, 3 DR templates created. So we're trying to wrap them nicely in a document with also implementation and really installation architectures. And from there, we really want to go into these different programs. Again, this is not a new profile specification, as some people might misunderstand. It's an addition to that. All right. That, I hope I was somewhat on time. I'm not sure when we started, but
oh yeah.
All right.
It's,
so that was my update.
Very good. So from a logistical point of view, those who are online, this is the opportunity to go on the chat window and put in your questions for Rolf. And then we'll get into the IP500 Alliance activities after we have covered your questions as well as the questions here in the audience. So for the audience, because of the audio challenge in the room, what I would suggest is go ahead and ask your question. Rolf will repeat the question so that the audience can hear, and then he'll answer.
Sure.
Yeah, thanks, Rolf. John Lindley from the SunSpec Alliance. So I think I understood that you said that the major California utilities are using OpenADR. And did I understand that communication is occurring over the public internet using secure TLS like we do when we talk to the bank?
Yes, so the question was whether the communication generally happens over the public internet or broadband that people have. And you know, it's a very good question. I don't know all the different programs, but for the most part, yes. So essentially, you can have a small building management system that you just plug into your router anyway. So it's an existing
right, so it's typically over the facilities broadband connection that they already have.
What some aggregators do, however, some aggregators might be a little more picky on that. So I know Enanog, for instance, is one of the bigger aggregators. They like to make sure that they don't run into any firewall issues, into anything like that, because they're on the hook for money, obviously. If they cannot deliver the power, then they're in trouble. So a lot of them use more dedicated links, either a dedicated link, wired link, or even cellular technology. I know a lot of their boxes, little boxes that go in the bigger facilities, and you have to understand that these facilities give them like several hundred kilowatts. So it's not like a home that gives you maybe 2 or 3 kilowatts if you throttle down the air conditioning. They talk to facilities, to industrial facilities that might give them even several megawatts back. So they want to have a solid link that is not exposed to any kind of firewall issues and so on, and they want to have direct connection, so they might use cellular links.
Right. So solar plants have gone through the similar type of experiences and transitions. So today all the plants are typically either connected to the internet through the facilities broadband connection, or they'll have a dedicated cellular connection as well. And so here, staying here in California, the interconnection rules for generators are currently being revised here in California, and it's going to require communications to the PV plants. And one of the the candidates, of course, for communication to the utilities is going to be OpenADR. Now, when I have some of these conversations in that context, when I point out and talk about, well, actually, we get this stuff over the internet, and we have servers on the internet, and you would just like go to that server and get a report. If you want to know what's going on with that plant, there's a URL. You just pull that thing, and there it is. Of course, you have to authenticate to get it. And we have security, but whenever I say that, they say, "Oh, internet, no, we're not allowed to do that." So what's going on here? How come the OpenADR stuff can run over the internet, but when the utility operations people, when I say internet, they just, we're not allowed to do that?
Good question. Yeah. I mean, what I've noticed over the last few years is that there's sometimes a big disconnect between the different groups, even at the utilities, right? so while the IT people might want to shield everything on their end, and of course we're also talking like green button, right, and things like that. There might be a different side of things where the operational people, have their separate endpoints. Like
they're specifically citing, NERC, SIP, right, critical infrastructure. We can't have systems, pingable, basically.
Interesting, yeah. So maybe, and now I'm again just brainstorming here because I've not heard that concern for OpenADR at all. So I'm kind of glad about that. But I mean, what I could see is that while the OpenADR server is, of course, situated at the utility or demand response program operator side, I could see that maybe that server is still not part of their critical infrastructure. That would be the only thing that comes to mind, right? That the server is somewhat encapsulated in their systems, maybe even physically separate. That could totally be. Or some of our members, like AutoGrid, for instance, will provide a solution that sits in the cloud. So it's outside of the utility firewall, if you will, and only obtain certain operational information from the head end. So that could be one of the reasons why it's not that critical for OpenADR.
Let's take some questions from online here. One of them is a loaded question. Would it be possible to compare the pros and cons between XMPP and MQTT?
Well, I'm sure it's possible, but
Does your 501c6 allow you to do this? Answer this question?
Generally, yes, but I have to admit that I don't know all the protocols out there, so I cannot really answer that. I think I recognized the names. It was probably on our list of like 50 others that the team looked at.
Yeah.
But I encourage, of course, people to just Google them. There's a lot of good information.
Right. And this is part of the challenge in our industry, is that we have a lot of very brilliant people. Sometimes they don't all get along. And that's what causes this type of bifurcation to occur. Two very well thought out methods of having IP-based technologies talk to each other without worrying about the underlying technology, but slightly different 11 herbs and spices. So the result is that these types of comparisons are actually not fair, because there's so much thought that went into the two, and I know exactly who the players are between these two. So I think it's best that OpenADR stay above the fray of these types of debates, and that leave it to each individual to see which one works better for their business function, rather than worrying about who's better and who's worse.
I don't think we need to go into a deep discussion on this, but I mean, we are just a user of this technology,
correct,
right? For XMPP and the other specs. So we're pretty open to whatever. You know, if somebody comes up with a better one, and they come back to us later and we want to use that, we might add that as well.
I think the litmus test for any protocol in this space is that if it can separate itself from the underlying hardware technology, it's good. The more you pin it down to the lower layers and say it has to be this recipe, the harder it is to grow the market. Fair enough? Yeah. All right. So next question, Brent Marsh asks, our DR system provides real-time metering feedback. How do we use this information with the ISOs for real-time market clearing of transactions?
Well, I think that kind of goes beyond the OpenADR presentation here. I mean, that sounds like transactive energy to me. There's, in fact, a workshop next week on transactive energy.
Very good. Good answer. Next question. Do you anticipate DR different signals for the various DR flavors, frequency, regulation, capacity, etc., beyond the current A, B, C, A, B, and C?
Yeah, so first I want to be careful. There's no C at this point, so it's only A and B if he's talking about our profile, which I assume he is. Yeah.
The 2.0 profile.
Right, exactly. No, I don't see any difference there really. I like to. I'm an engineer by heart, even though I'm not building code or anything like that anymore. But for me, it's the same information that's being conveyed. It's electricity, either demand or excess. It's pricing and so on and so forth. So I don't see any differences at this point. We have not seen, I should say, a use case that would go any beyond the A and B profile.
Okay, I would just like to caution the people who are online that when we share the desktop, any message that's sent privately is actually public. So everyone can read those. So just consider them public questions at this point. It's the kind of encryption where everyone knows the encryption key. All right. Dave Lawrence asks, please describe the relationship between SIM and OpenADR.
Yeah. So let's see how much time do we have for that.
It's okay. It's important to have these questions answered.
So
keep it going.
The very low-level underlying ideas in the energy interoperation specification are somewhat related to SIM. However, that does not mean that OpenADR is in any ways at this point compliant with SIM, if there's even something like that, or directly connected at all at this point. So the SIM is a data model where a lot of people in different shapes and forms, not so much interoperability focused the way I understand it. And so really what it boils down to, there is no direct connection between OpenADR schemas and schemas. So what we are doing in the IEC, you saw earlier this PAS, the publicly available specification. So that's the first step within the framework there. And we have three distinct tasks that we are looking at. The first one is this PAS, get the specification out there, because they liked it, they wanted to use it, they wanted to use the nomenclature here, so they adopted VTN, BEN, things like that. And overall, that structure that I showed you in that document, that table of contents, really very much took energy into operation, ADR ideas, and put it in there. The second step now is to go back and extend the SIM with anything that's missing that's coming out of OpenADR. The SIM, as some or a lot of you might know, has been used extensively, of course, in head-ends, in communication, in the systems, within the grid, between substations maybe even, and so on and so forth. But it has not communicated down to a resource level, to a facility level at this point. If it does, in some instances that might be, so don't shoot me here for that. I mean, I don't know if any implementers have coded it down to the resource level, but most of the implementations don't. They haven't really looked at the facilities. So what we in the second task now try to do is we're trying to define what are the specific demand response functionalities that are currently missing in the SIM to connect to the buildings or to connect to OpenADR in that sense. So that's currently ongoing. That would kind of bridge the gap, if you will, between SIM and OpenADR. And then in the next phase, the phase 3 basically, we will create an adapter specification. So that's kind of between OpenADR and the the IEC world. So we're working on that in these working groups over there, where we want to build an API that connects a SIM-driven head-end with an OpenADR functionality, so that the embedded server there could then use SIM structures to determine whether certain events are required and things like that. So this will be a little bit of an abstract API, because again, the information that's being exchanged in the head-ends and above, they are not directly correlated, at least not at all times, to an OpenADR message. So there will be some intelligence needed in between. But that's essentially the next task that will be done in the IEC working group. And then in the end, we'll fuse that together. We'll take that PAS document, basically OpenADR 2.0b, and fuse it with this API specification to create, in a sense, a SIM-adaptable demand response mechanism.
Yeah, key thing in this space is understanding what elevation you're flying at. So OpenADR has much higher level goals, whether it's load curtailment or it's critical pricing. So at that elevation, you give maximum flexibility to the facility to achieve that goal. So if you try to be too prescriptive at that level, then you're not going to give much flexibility to the facility. So every location in the grid, all the way from generation down to the end appliance, has relevant protocols that have the level of detail that's necessary for it. And so OpenADR achieves that goal by maintaining a certain amount of neutrality on platforms. I mean, yes, it's using the IP backbone, but beyond that, it's telling you you need to work yourself out. If you want 20% reduction in energy consumption, you figure out how you are best going to do that. Craig, you had a quick question?
Craig Lewis with Clean Coalition. Thank you for this great presentation. Along the lines of what Erfan was just talking about, if I'm a utility and I'm providing profiles to get the services I want from the various end users out there, it sounds like I need to define profiles, or are those profiles predefined in the ADR platform? One question, and an offshoot of that is there's ADR, OpenADR Japan, OpenADR Korea coming. Are those going to be different profiles, or is everything going to be the same? And then the second piece of the question is, if I'm an inverter manufacturer, let's say, and I want to have an advanced inverter that can provide reactive power provisioning, and I need to, do I have a set way I have to respond to those profiles, or is that negotiated with whoever deploys my inverters and the utility?
I hope I can remember all these things.
Like practically, how does this actually work?
So the first part of your question was whether a utility or a demand response program operator would need to create a profile or some kind of a program, I would like to call it for now, with the resource. And the answer to that is yes. So you will have to define what it is that you want to do. You will have to have an objective. But we are working on on these implementation demand response programs that I showed you in the end. So that should make it much easier for you, because then you can just grab one of these, right, and say PG&E recently started trials for a small medium business thermostat program using OpenADR. So that would be, for instance, one of these profiles that you could use, right? If you want to do residential, you want to do either peak management or maybe even load following, something like that, frequency management, you could pick one of these direct demand response programs, like a thermostat program, and you could use that directly. The idea is really that at the end of the day, and this could take until next year for sure, there would even be a template for an RFI from you as a utility.
We are a little short on time, and what I'd really like to do is bring Phil Beecher to do the presentation in between, to give Rolf some time to rest. He's been talking for a whole hour, and I'm sure he could use some fluid. But I will take two more questions here, and Matthias, we'll get back to you in our final Q&A. So Dave Lawrence, important point, he says, we took SIM down to the device recently, FYI.
So I'm glad I mentioned that it's possible.
Great. Yes. And then Roger Alexander from Eaton says, OpenADR does allow for internetworking with third-party end device protocols such as SEP. However, are there any alliance considerations of compression, such as EXI, and transport protocols such as COAP, Constrained Application Protocol, that would allow greater end-to-end opportunities for OpenADR to be transported directly to more constrained end devices?
Yes, good question. Thank you very much. I think I've seen that in an email before.
Yes.
Yeah, I mean, valid concerns. I mean, this is probably also could be a longer discussion. I mean, I think what we are trying to do right now is we are trying to understand what the device restrictions could be. I know some manufacturers and utilities have looked at that and have determined that there might be very limited devices like a thermostat that would not be able to, say, parse an XML. Yes, so this is certainly possible. But what we are trying to understand also from in the message that we received there, as we're actually discussing that in a working group, so just to let you know, is what are these restrictions? Yes, what's mentioned here, they are good transport aspects. You know, it's possible that we could think about that. But so far, I have not had a manufacturer directly coming back to me and saying, I don't have enough computing power to do this. I can't do this. I can't do that. And everybody should keep in mind, cybersecurity is a big issue, and these devices will have to have some powerful engine to be able to actually satisfy the security requirements. It's not so easy to calculate your keys in a specific time frame. You know? If you use ECC, it could be a little faster. If you use RSA, you know, somebody did the math on like a small, forget what it was, small ARM processor to calculate a 2048-bit RSA key to like 16 minutes or something like that, you know, which would of course be useless for for communication if it takes so long to establish a secure connection. But again, keep in mind this is mandatory. Unless the utility decides to drop a lot of security, like you and your router at home, if you decide not to use a password, that's up to them. But we cannot design around that. But again, we are taking this seriously, of course, for constrained devices, and we are looking at that.
All right, so real quick here, Ray Hayes asks, conformance does not guarantee interoperability. Will OpenADR.org maintain the matrix of proof-specific VTN, VEN, IOP results? Long live abbreviations. Okay.
I suppose IOP is interoperability. This context, something like that. Okay.
Yeah.
Hi, Ray, by the way. Yes. So we in fact publish test reports, and we maintain the traces and results of testing. So that's why we also choose an accredited test facility, like Ceticom is one, TUV is one. There is the other test house present that I haven't mentioned. Intertek does it. A lot of them are accredited according to 17 or 25. In our with them, we require them to keep the test data, and we have actually seen so far very, very positive feedback from the market. Things seem to work very nicely at this point. I mentioned in Japan, they had the first trial where they communicated from the utility through the Bazaar University and used any kind of service that was there, and it worked just fine, even though these people just got together there. And we have not heard any other issues in the field here, anyways. So yeah, we're trying our best to keep the interoperability solid there. Again, I want to re-emphasize, a lot of people think of interoperability as kind of plug and play. So you buy something off the shelf and you plug it in. We're not quite there yet, and I think that's the case for most all of the smart grid technologies, because it is not entirely defined what the utility wants to do with it.
Correct.
Right? Like I said before, that's why we're designing these specific DR programs, so that the utility could really, in the end, say, I want to have a residential thermostat program that does X, Y, Z for our resources, and then the customers could go and buy thermostats that conform to that particular demand response program.
Correct.
That's one. In fact, really, I wanted to answer quickly Greg's last point. I'm not sure if the second point was ever answered, but at this point for Korea and Japan, it is not envisioned that there will be other protocol standards. They will probably have different kind of use cases, and the demand response profile, these demand response program templates might be different. That's what Japan is doing right now. They in fact took OpenADR, they make it mandatory, they make OpenADR certification mandatory, and then they created their own spec for the demand response program, how that program works, how they connect devices, what the incentives are, and so on. So that's all different there. So we expect other companies to do that as well.
All right, so at this point, I can safely assume that we will need 15 more minutes than our regulated time up to 2:30 Pacific in order to include all the comments of the two speakers and the Q&A. So Gary Sorkin from across the room asks, up to now, OpenADR is dealing with load shedding. How is it planning to deal with adding power via endpoint energy storage systems?
Yeah, so for me, it's the same thing. For me, it's really the same thing, whether the resource generates energy or the resource saves energy and provides it back. From an OpenADR perspective, for us, that's very much the same. You can use the same levels, for instance, if you do simple levels. You could even do, you can ask for shedding or curtailment or other energy numbers. You can ask for a specific number of kilowatt hours, megawatt hours, and so on. So at the end of the day, it just comes back to the agreement between the demand response program operator and the resource. And maybe I should mention that, anyways, that a lot of people misunderstand this. A lot of the functionality that demand response programs offer are defined in the contracts. There's always a contract between the participant, the resource, and the utility. Like for those of you living in California, you might participate in, say, a PG&E program with your thermostat. So if they have if they encounter like high amounts of energy usage, they send commands to your thermostat. They invoke an event, and they might give you this thermostat for free. They even have somebody install it. But somewhere in the fine print it also says probably that you cannot just take it off. Or so essentially you enter a contract by accepting their free thermostat. So obviously these are not that like rigorously enforced. So I have a Nest thermostat. Not telling. But I still see my PG&E thermostat once in a while in the cabinet showing an event coming through. So.
Let me finish the two comments online, and then we'll take the last to Matthias, and before we move on to Phil's presentation. So let's keep it really brief now. Chuck Thomas from EPRI asks, for OpenADR to interoperate with other open standards, maps between the two standards must exist. Is the Alliance working with other standards organizations to develop and maintain such maps?
Very, very good comment, Chuck. I have to say we have so much to do lately that we haven't really pushed a lot on it. We did start dialogues with SEP2. We started dialogues with Multispeak and with others. But to be honest, we need mutual cooperation there, and some of them it was not on their top priority list. So I know that a number of our members and also our test system vendor, Quality Logic, they have in fact done a lot of the mapping. They have done SAP2 mapping, they have done Multispeak mapping. So it has been done by a number of our members, but the Alliance, I have to admit, we have been dragging our feet on that a little bit.
Yeah.
I totally admit that.
One thing I will tell you, this is my experience in the last 5-6 years of being in this business, is that if it's not driven by business, boiling the ocean is a futile exercise. So when you have a business function, you'll create a profile that supports that business function. You will know exactly which things to map. In this infinite world, you will make it finite by only having certain degrees of freedom locking into a profile. And then the appropriate mappings make sense. If you try to do any to any, you will not have enough R&D dollars to do it. And if there's no business function, there's no force function to make it happen. So I always go back to this, that while we are technologists, well, we have to keep our business caps on. What do the utilities want? What do the IPPs want? What do the aggregators want? And then try to create profiles that support those functions. All right. So Brent Marsh, do you foresee any integrated OpenADR product systems rather than just server, software, VTN, VEN?
Well, that's an interesting question. We would need to elaborate that on a little bit more, because the concept of the VTN and VEN are the two basic ideas of OpenADR. There's really nothing else. Okay. Either you are a client or you are a server. However, of course, you can have an integrated client in embedded devices. You can have an integrated client in energy management systems, and we see the clients being embedded in the cloud. So all of this is possible. So I'm not exactly sure.
Okay, we'll leave it at that. Matthias and Jamal, you had quick questions, hopefully?
Yeah. Quick, of course, online. Just folks, fire me an email. My email is there on the screen. Right there. So I'll try to address that in the next 2 days.
Okay, so I will move to Phil's presentation while you ask your questions, and that way we'll have a smooth transition.
I can go first. So quickly, also in the interest of answering the interoperability question that this gentleman asked, and in view of what OpenADR, where it resides in this open layer, I see that it's really necessary to go down to these secondary objectives very quickly and to end up with these templates. And I'm just wondering, these templates, they should be certified templates as well, because they would tie down those, what Erfan also mentioned,
Correct.
Kind of this big universe, tie it down to some small.
Absolutely.
Yeah.
So the question was whether the demand response program templates that we are creating, whether they will become also certifiable in a sense. And yes, that's absolutely the idea, that we will do that. Think about it similar to DOCSIS, cable modems, right? Very similar path in the past. For those of you that might have looked into that industry a while back, Originally, DOCSIS also just defined the communication for cable modem systems. Afterwards, they realized, okay, you have the Comcast, you have other players globally, locally, and so on. They all want to transfer the same information content, but they display it differently, right? If you sign up with Comcast, you have a different menu structure than with another provider. They want this button to record and not that, and things like that. So I bridge it in the same way here, that now we have the communication protocol. Now we extend this out to the operator level, if you will, right? Similar to DSL. So you have profiles that run. So if you look at DSL broadband, you would have like an AT&T way of implementing it, and so on and so forth. So yes, so we want eventually to end up with maybe just hopefully less than a dozen smart response programs, fixed programs, and we want to be able to have vendors certify against them. Really, the testing shouldn't be that difficult, because we would just do the same testing as we do already, but we would stick the real information content in the messages.
Jamal?
Alliance, the devices down to the appliance, and actually running and I think that also, in addition to this, in relation to Chuck Thomas's question, how much work has been done with OpenADR and ACP 2.0? And I think is there the mapping, such as the one that was developed in
So the question is whether OpenADR envisions to really control devices eventually, and again about the mapping between OpenADR and other technologies. So I would like to make a general statement to that question first. So OpenADR is not a control and command protocol. OpenADR provides information. Well, it's both ways, but we are not flipping the switch, as I like to say. So we are not turning off a pool pump. We might tell a pool pump that there is currently, like for instance, a load shedding event going on, that this pool pump is enlisted to participate. What the pool pump does with that is still, it's on the pool pump's end, right? So we are not saying, turn it off. That might be a function of the controller. So there might be a controller in front of it that says, okay, I'm supposed to save energy, so I'm going to throttle down this variable. I don't know. Or you have a building management system here that receives an event today between 2 and 4, save some energy, and they might say, okay, I'm not actually upping the temperature in this building, but I'm throttling my variable speed rooftop units. Right? So they might have different ways of responding to this event. That's why I always like to say that we are not doing command and control with individual devices, because that's where then, say SEP, EcoNet, things like that, maybe even since their later IP500 comes into play, where they have their network, their devices, to an extent even YSUN, although YSUN we work with differently. We would be able to communicate over YSUN, for instance, to the buildings as well. But that's where their strategies come into play. And that's where the mapping becomes interesting, right? Between received events from OpenADR that have to be translated into local area network or home area network or building area network commands. And that's why it's also not quite so easy to say, okay, we map an OpenADR event to an SEP event. It's totally possible. We did that. Quality Logic did that. Fairly straightforward. But again, it depends on the strategy that this building deploys. So it might be that, okay, we turn off one thermostat, but not the other yet. Things like that. So there's a lot of flexibility in there.
My question is that where are the boundaries? Do you expect to, what I've heard from you is that there is an overlap between OpenADR, from what I understood, and the SEP. And
crosses that boundary.
It could, yes, it could. In fact, yeah, now I see what you're saying. Yes, I mean, in certain instances, it could, of course, communicate, and again, communicate with the device, a particular device, like this thermostat. So, to give you an example on the architecture, we see some of these thermostat programs coming up that talk to a cloud interface. So, like thermostat manufacturers are now building systems where the thermostat itself is actually very, very simple. It has maybe a nice display, maybe it's shiny, maybe it's round, maybe it's square, but it's really just a shell. So it has, I suppose, it has a TCP/IP client running on it. I don't know actually, but they connect to the internet and can only do basic commands in that thermostat, right? Everything else happens in the cloud. So we have some of these manufacturers that build a cloud client, an OpenADR client, that communicates on this level with the utility and then controls the device, right? But again, that doesn't mean that you couldn't build a module or even a pool pump that has OpenADR built in and becomes a web-capable client. I mean, that's for the manufacturer to decide if that makes financial sense for them.
Yeah, let's take this discussion offline afterwards, because it's really important, especially those who are online. A lot of them are on the East Coast, and it's getting late over there. So while they transfer the microphone, I'm going to introduce Phil Beecher. So there was a time when the rule was that the Brits discovered it, the Americans introduced it to the world, and the Japanese made sure everyone had one. And that rule worked for a long time. Now there's Korea and Taiwan and others who make sure everyone has it. But that innovative part, the discovery part, is still very much in the hands of Brits. And once again, you know, we've got Phil Beecher, and I've been following his contributions to our industry for now about 5-6 years. And if you think about a low-power, narrow bandwidth network like that is specified by 802.15.4, just think about how much innovation went into it. So you are trying to be clean tech. So naturally, you don't want to use a lot of power. You are dealing with networks that have a lot of physical boundaries. They have a lot of hindrances. So you want to create a mesh in order to increase the probability of transmission from point A to point B instead of just doing it in a single hop, finding alternative routes. And then you're trying to add a layer of interoperability on it with the IP. And that starts putting the pieces together for what the Wi-Sun Alliance is all about, and then getting vendors to agree to these recipes, if you may, so that there will be greater interoperability. That requires a lot of pioneering work, and this poor guy has crossed the pond one too many times trying to convince all these people, and he'll show you slides in which he'll show all the companies that are now part of his alliance. But his contributions have been very valuable, and I salute you, Phil. You've done a great job, especially first with 802.15.4, and then thinking of all the building blocks that come together to make it a business-friendly standard. So thank you.
Thank you.
All right, so we've got Phil.
So first of all, can people hear me?
And I will check on the chat window to make sure that that's the case. So if you are online, could you tell me if you can hear Phil?
Is that one again?
Yes.
Oh,
Joe.
Good. Okay, if one can hear me, that's
Wonderful.
great. Okay, and then if you could focus back on the screen, that's
Yeah.
perfect. Right, so first of all, thank you very much for inviting me, Erfan. Actually, I invited myself when I heard Rolf was speaking, and I was going to be here, but thank you for tolerating that. I think I've got about 30 minutes.
Take your time.
Well, don't say that, because there's a huge number of slides here. So what I plan to do is to go through them fairly rapidly, and then there'll be some time for question and answer, and I assume you'll be posting the slides
Yes, right.
for the participants. Okay, so the contents of this presentation. An overview, what is Wi-Sun Alliance and where does it fit in smart grid technology? A little bit bit of the background on wireless and smart utility networks, particularly 802.15.4G. Something about standards and interoperability and the need for Wi-Fi Alliance, because quite often it's difficult to distinguish. We have a standard, why do we actually need an industry alliance to make it interoperable? And then something about really my personal view of the role of industry alliances in testing and certification, and you probably will have seen some of the stuff in the past, both in OpenSG and in SGIP. Then overview of the organisation of Wi-Fi Alliance, a little bit of background about why we've done it the way we've done it, some testing strategy, a bit of history of interoperability events, and then collaboration with other organisations. So one of the key things I think that comes about with delivering what we need to the end users should be about collaboration. Industry alliances have their own focus, but doing it in silos doesn't help the end user particularly well. Okay, so first of all, what is Wi-Fi Alliance? So we have here across the top the relationship between standardization bodies, industry alliances, and trade markets. And I've taken three here. 802.11 has the Wi-Fi Alliance, which certifies and creates a good program which brings a reputation for Wi-Fi in 802.11. WiMAX did the same for 802.16, and the Wi-Fi Alliance was formed to take this role based on 802.15.4G. So our scope, and it's most important that people recognize we only look at communication profiles. So we're not interested in application layers. Well, of course we're interested in application layers because there's not a lot of point doing this if you don't have one. But we don't go about defining application layer profiles at all. We collaborate with other industry alliances that do so. For example, OpenADR. We are currently focused on IEEE 802.15.4G based technology with IPv6 as a transport. We're implementing a testing and certification program to ensure we have operable products, and I'll cover that a bit more later. And we're supporting our member companies through marketing initiatives and interoperability events. So we have two focal areas. One is to help our member companies ensure they have interoperable products, and then the other is to help them sell them. And that's a global effort. We've been focused on smart utility networks and related applications, such as smart cities. A lot of this technology goes beyond just the utility network. So effectively, we're an ITCA for peer-to-peer wireless mesh-based technologies on 802.15.4G. So if we look at this picture of the smart grid, which most of you on the here and on the call will recognize, our focal area is in two places around field area networks and also in premises networks. So to support these two major areas, we have two profile working groups. The profile working group on the left is what most of you here will probably recognize from Wi-Fi Alliance technology, is looking at the field area network. For those that are aware of Japan's smart grid, this is what's called A-route in the Tokyo Electric Power Company. And this is communication between smart meters, AMI, and DA networks. The FAN working group has two co-chairs who are from Cisco and Silver Spring Networks. So that's Paul Duffy from Cisco, who you probably know, and Tom Hurst from Silver Spring. So we have a draft specification for our field area network. It supports multi-hopping operation and frequency hopping, encryption and authentication. So I'll cover a bit more about this and the current status later on. Then our other primary activity is we have an Econet profile working group. So as people may be aware, TEPCO recently introduced the requirement that hand devices support Econet. Again, the relationship here is slightly different from US applications in that for TEPCO there is a smart meter with a communications interface to the HEMS controller, the home gateway. This is the only specified part from TEPCO's point of view, which lets them maintain security here. And the HEMS environment is all within the consumer premises and under the customer's control. So YSUN supports this interface here, and in October last year, we were appointed by TEPCO as the test and certification authority for this interface. So that obviously got us a lot of interest in Japan and has effectively done some great marketing for us in Japan. The Econet working group is chaired by Dr. Harada from NICT, who's now professor at Kyoto University, and technical editor is from Toshiba. So we have an approved specification. It's based on 15.4G and 15.4E, 6LoWPAN, IPv6. It supports AES, and the authentication is PANA, and we are standardized in Japan under TTC JJ300.10. So a little bit of marketing hype about wireless mesh for field area networks, which you've probably seen many times over. Flexible, reliable, resilient, adaptive, self-healing, low OPEX, which is really important. And it supports high data rates. 15.4G supports data rates from 50 kilobit per second to 800 kilobit per second. Bidirectional, and we can support battery power for gas and water meters. Good for AMI and DA. So why did we need a standard? Just a little bit of the history of 15.4G. So in 2008, there were actually no wireless communication standards for peer-to-peer field area networks. You could argue that 15.4, 2.4 gig, which was deployed some places, was, but it wasn't what was really suitable for the networks that the utility companies were putting in. So a standard which was 15.4G. And that had a focus on smart utility network communication with a primary application area for field on neighborhood area networks, optimized for mesh, and it supports large-scale outdoor wireless mesh for utility communication. And one of the key issues here was there were a number of companies that were deploying proprietary wireless mesh technologies. And if you look at our membership list and the participants of 15.4G, you'll see who were deploying them. Well, what's interesting is they were mostly based on common technology. So particularly in the US, where spectrum rules are pretty favorable in 902 to 928 for frequency hopping, everybody was doing it, but slightly differently. So 15.4G wasn't about really developing new technology. It was to take the proven technology and create a standard to allow us to provide interoperable products. And this was all starting at around the time Dr. Arnold was saying, don't reinvent, but make things interoperable. So that was part of our mandate. So our timeline for 15.4G. In May and July 2008, we had the early interest group meeting. In that time, there were presentations from PG&E, FPL, and other utilities. In September 2008, the study group was formed. November 2008, the project was approved. So all was going really well up till then. And then the work really started. So we had our first meeting of 15.4G in January 2009. It took us a year and 3 months to get to the first letter ballot. I noticed Monique smiling. There are probably others that were participating. I noticed on the webinar as well. So it was a hard time for quite a few of us, but we got there in the end. So by March 2012, 15.4G was approved by IEEE Standards Board. So some of the features actually turned out to be backward compatible with an install base of 10 systems, and that's not an exaggeration. Again, high performance, high data rate, low latency. Key thing here is that it's low cost and low complexity, so a mature technology with low R&D costs to recover, and it's global and proven. One of the things that isn't stated here is that 15.4G supports frame sizes up to 2048 octets, so can carry IP500 directly. So, yeah, so the reliability comes from, well, particularly from the fact that we support 4 FCS. So error detection is pretty good, and then you have because it supports resilient mesh through upper layers, then you have the ability to find new routes, routes if there are routing problems, and also frequency hopping. So North America allows us to frequency hop. So it's pretty good at finding, problems when you might have multi-path problems or interference, good for interference mitigation.
If you lose a packet, I don't know all the technical language, but does it have a positive confirmation that a packet's received?
Yeah, but it's not guaranteed delivery. So 15.4 supports acknowledgement. The upper layers will know if a packet delivery fails, but it's not, you have a number of retries at 15.4, but you expect higher layers to resolve that. And in some environments, then obviously you want to have guaranteed delivery. In other environments, it's better to just throw that one away, recognize you've lost it, and get the next one.
Yeah, I think also the frequency being 900 megahertz versus 2.4 gives you more range.
Yeah, you get really good propagation.
Yeah, and then also
up to 5 kilometers in open field sites.
It's getting quieter with time as people are moving to higher and higher frequencies in the ISM bands to 2.4 and 5.8. So the 900 is kind of like a sweet spot below a gigahertz. And combine that with beam focus, and those kinds of things, you can create very high reliable networks.
Not really a high reliability network in the sense of, let's say, like we talked about, where you have other mechanisms in addition to, let's say, error checking. Not that,
Well, so 15.4G does actually support field error correction as well. So you have a number of things there that increase the reliability. But as you say, reliability comes from multi-layers, and the 15.4G and the PHY and the MAC provide just a framework for improving reliability.
The key thing to point out here is that there is a energy per bit for spectral noise ratio, EB over N0. And if that between 2 points is below a certain level, the probability of successful transmission drops precipitously to 0. So all the retransmits won't help. What is good about the 900 megahertz in the ISM band is that it's favorable physics for you, so that EB over N0 ratio looks good between consecutive points in a mesh.
Great, thanks. Specify 900 megahertz band, or you could put this protocol on any
So we are defining profiles for different frequency bands. So one of the problems of sub-gigahertz ISM is every geographic region has different spectral regulations, different part of spectrum. So the US is very favorable. We have 902 to 928 megahertz, allows for 1 watt transmission frequency hopping, which is fantastic. Japan is also fairly favorable in that they allocated spectrum at 920 megahertz for this sort of application. Not as much bandwidth, not as high power level, but prior to about 2010 or 11, there was the only spectrum available was shared with passive RFID systems. Europe has opened up spectrum just recently in January in 870 to 876 megahertz. So the previous spectrum was really tough to use at 868. But now there's more spectrum available, 500 megawatt transmission and decent range. And you're seeing smart city applications using that. Shall I carry on going?
Yeah. I just want to say that Phil is being very humble. His cat herding ability with the priority action plan with NIST and getting all of these people with their different, as I mentioned, 11 herbs and spices to align to come up with a common standard for the thing that they all called 802.15.4G is nothing short of a miracle. So go on.
So we have 15.4G, which was a standard, in quotes, for communications. Now, one of the interesting things about IEEE 802 is the voting rules of this are such that a standard is basically everything everybody wants to put in there that represents a big enough vote in the pool for people to do it. So if you look at 15.4G, not only does it have an FSK PHY, but it has 2 flavors of DSSS, and it has OFDM, which has 5 flavors within it. So what was still needed? Well, basically, is to take all of this stuff and find out the bits that people actually want to implement and what is most appropriate for any particular area in the smart utility network application, and then pair out all of the options and get something that's interoperable. Because options do not mean good interoperability. It's the exact opposite. And the other thing was a testing and certification process. So IEEE 802 writes standards, and it doesn't look at testing at all. So if we look at the application areas, there are a wide range across the different utility applications. So HEMS is one, AMI, DR, and DA, as well as low power meter reading, e.g. gas, and smart cities. So, and you have different requirements for each of these. So for gas, you don't necessarily need super fast readings, but you do need low power consumption. And for DA and DR, you need sort of well predictable latency. So what we do is we define communication profiles to support these application needs. Okay, so if we look at our role, and I've already said this, but I'll say it again. So you have a standardization body, and in this case, in our case, we're talking about 802.15 and 15.4E and G specifically. The standards have got great flexibility, but we need to restrict those to improve interoperability. And then the other body that we use standards from is IETF. So the Alliance, we identify required functionality and then create a profile from a standard or a selection of standards that meet those functional requirements, and then we create a test plan to verify product compliance with the profile. And as I'll address later, compliance means performance and interoperability. And then we do our certification testing through an approved test lab, and the test lab verifies that performance and the interoperability with other conformance products. At the moment, Whitestone Alliance is providing its own certification, but we're using test labs that have IEC 65 bodies associated with them. So we were established in 2012 when the standard was launched. Our main purpose is basically take these standards, do something useful with them, establish conformance testing to verify product conformance, define a multi-vendor interoperability testing, the criteria and the plan to verify interoperability between implementations. We use third-party testing program with appointed test labs. In addition, we organize interoperability testing events for member companies. And there's a slide later that shows just how many of those we do. And we contribute to and collaborate with other standardization and certification. We now have 60 member companies, including utilities, product software. So our promoter members, Analog Devices, Silicon Company, Cisco, who you've probably heard of, Fuji Electric are a metering company based in Japan. Murata Modules, NICT is, I guess, close to the NIST of Japan. Omron, a system provider. Osaki are a metering company. ProCube, a software vendor. Renesas, chip company. And Silver Spring Network, who are another metering comms company. Our contributor member companies are listed here. I apologize to the more recent people that have joined that your names are not on here, and logos, but we'll bring this up to date soon. You can see them on the website. We have 2 observer members, test labs, who are Telec and TUV Rhineland. Both Telec and TUV Rhineland are Whitestone approved test labs. TUV are currently certifying products, and we have 19 certified products that have gone through their labs so far. We set quite a high bar for test labs to participate and become approved, as certain people here will bear witness to. Okay, bit of a general overview of our organizational structure. So we have board of directors, executive committee on the top right, who are members of the board and manage the day-to-day running of the organization. The vertical stripes are our committees. We have marketing committee, technical steering committee, and testing and certification committee. The yellow horizontal stripes are our profile working group. So each of those represents an application silo. But to keep those guys in check, we also have technical domain working group. And I'll come to that in a minute. So the technical steering committee basically manages the technical activity of Whitestone Alliance. So we review marketing requirements, determine technical strategies. This coordinates the technical domain and profile working groups. We review the deliverables from the working groups and interest groups and recommend formations of new working groups, interest groups if necessary. And the other thing that's important is to continually review existing and new standards from other organizations for applicability. There's no point reinventing the wheel, basically. So here's the structure. As I said, applications are the profile working groups, and then we have a committee that represents by experience and expertise, map, and interface. So the profile working groups, the Econet group is defining and managing Econet profile specification, and the field area network working group defines and manages the field area network profile specification. Econet working group is misnamed in that it's really a communication profile for Econet, and and not an application layer. And the profile was developed based on the requirements of TEPCO, but has applicability in other areas. So it's just another limited use of 15.4G and 4E IPv6. So if we look at the structure here, everything is based on 15.4G, MAC layer, 15.4, 15.4E extensions. We've also done some work through ANSI 4957.200, which is a specification that was developed in TIA. One of the things missing from 15.4 is a methodology for frequency hopping and blacklisting of channels, etc. So 15.4 provides a centrally synchronized hopping mechanism, but certain of our participants consider that that's not sufficiently scalable for multiple thousands of nodes on a field area network. So the 4957 has a device-centric hopping mechanism such that you can detect your neighbors, know their hopping patterns, and track your neighbors' hopping patterns, which is as scalable as you want it to be. Then we have the profile interface layer, and in the case of the FAN field area network stuff, we're using defining either UDP or TCP with IPv6, 6LoWPAN. Hence, for Econet has similar. We also have a relationship with a Japanese organization called JUTO, which is Japan Utility Telemetering Association, who are a collection of gas utilities and gas meter vendors. So we're working with them on using 15.4G and standardizing and helping them with their certification program. We have an interest group on M2M activity where we're defining what M2M objectives and activities the Alliance should participate in and what technical characteristics are applicable. And again, this has to be done within the landscape of every single other M2M and IoT type organization going on there. It doesn't do anybody any good to reinvent the wheel or overlap with their activities. So as I mentioned, we have the domain working groups. These are primarily there to ensure consistency of the relevant technical aspects in the profile specification. So it's very easy for one working group, an application-oriented working group, to say, oh, we like this functionality from this part of the standard. Somebody else says, we like this functionality. And then you end up with two communications profiles that are non-interoperable, which is just daft. So that's what we're trying to do with these groups, is to ensure consistency. We have a number of technical specifications. The groups prepare a spec for each of the protocol layers and the protocol implementation conformance statement. For the field area network, we're actually generating the PICs automatically from the profile specification. So the Econet Lite profile spec is complete. You'll see the test program later. The technical profile specification for FAN is feature complete. We're conducting interoperability events and refining the spec at the moment. So let's look at from working groups to testing and certification. So on the left come in marketing requirements. They go into the profile working groups. They're further developed by the profile working groups. There's interaction between the profile working groups and the domain working groups to ensure consistency. From there, we produce a technical specification which is delivered to the testing and certification committee. They create conformance and interop test specs and the test program and test plan, and that's delivered to the test lab, who then are expected to implement it. Obviously, the test labs are involved in this cycle as well. So The Testing and Certification Committee, its role is basically to enable and define the testing and certification services for our profiles. And we define and administer the certification program, define conformance and interop test procedures, also review technical specifications and do the change management on the test specs and the profiles, and we organize interoperability testing. So the chair of the Technical Steering Committee and the Test and Certification Committee is a YSUN employee who works exclusively for YSUN. So that's trying to reduce any conflicts of interest that we might get. Here is our certification process. This shows the responsibilities of each of the stakeholders here. So YSUN Alliance develops the test spec and certification policy, establishes the testing network and product testing and certification. We take the output of this and we feed it back into standard setting organization. So we are not a standards setting organization, purely an ITCA. Nothing we own or nothing that we have, we own. So we do have an IPR agreement, but most of the IPR is basically owned by the standards organization. And then, as you can see at the bottom here, we are in a position to appoint accreditation bodies should we wish to do so. At the moment, there has been no need. But if we have end users that require independent accreditation of certification body, then we can do so. Our scope, again, as I mentioned, certification scope, radio, Wi-Fi, medium access control, and network transport layer. Application, outer scope. So this basically just reiterates probably what I've said. So the TCC develops the test strategy, and that will, part of the key discussion is how much conformance testing do you do, how much interop testing do you do, how do you go about verifying routing works properly, what do we do in terms of security testing, and each of those things will be different or may be different for different profiles. From there, we come up with test specifications, we appoint test labs, determine test equipment. So with ACANAT, we were very fortunate that the Japanese government provided some money to help with the development of test equipment. So that was fortunate in some ways, but in other ways we had two test equipment vendors that developed independently test equipment. So then how do you go about verifying those? So part of our challenge there was to verify the compatibility between the different pieces of test equipment, which actually went incredibly smoothly. But now we have additional vendors that are providing test equipment, and we have a methodology for assessing them. Now this works nicely for RF, where test labs traditionally have already made an investment in expensive equipment. Now we have a mechanism to correlate their equipment and any software they add to that to help automate the testing. For interoperability testing, we use certified testbed units. These are golden units, but renamed because certain people believed there was too much baggage in the name golden unit. And then we have, as I said, we have interoperability testing events. So we have two parts of testing: conformance testing, where we assess the device under test for conformance to the spec, and interoperability testing, where we assess devices for interoperability with the reference implementation. So someone asked the question of Rolf earlier on, is how do you verify against all interoperability in a matrix? So for the Ethernet type implementations that we're doing, we have a limited number of vendors that have been approved by TEPCO to provide the meter end, and we can use those as the verification tools. For the field area network, we are actually considering at the moment, do we build a whole matrix? So in other words, a device comes to be certified, it's tested against every other certified device, and then added to the pool. So the further in you come, the more devices you test against. And that is under discussion. If anybody wants to join that discussion, join Wi-Sun Alliance and come play and join the party. It's fun. All our testing is conducted by Wi-Sun appointed independent test labs. We use third-party testing at the moment. We'll continue to do so until things are sufficiently mature or the test labs can't handle it anymore. And the device under test must pass all relevant tests to be eligible.
Phil,
yeah.
It's very interesting to note the experience of Japan with cellular telephony and how they went to a proprietary protocol and lost market share because their cell phones didn't work in the rest of the world. But this time around, they're taking such an international collaborative effort when it comes to this space.
So I think, most definitely. And I mean, if you look at particularly TEPCO, but other Japanese utilities are picking up, they've gone for standards-based technology. Not exclusively wireless mesh. So for the Route B stuff, they're also looking at PLC, but again, standards-based. And OpenADR.
Right. And so the connection there with TEPCO is the utility that owns Fukushima. And with those nuclear power plants now out of commission and having this 55 hertz and 60 hertz issue in Japan, they have to heavily rely on demand response in order to be able to, because there's not much wind except in like the north part of Japan, and solar is not the best over there. So they really have to actively implement DR programs. So this underlying technology with OpenADR on, is necessary for them to survive.
So I think, so overnight there was just a shift in requirements because they went from a power surplus to a deficit. Needed a complete cultural change.
Is it fair to say that the OpenADR is the application layer that rides on top of this? Like, could be the application layer?
Well, OpenADR will come across a wide area network of some kind, and then will come to a customer prem. It could also come through a utility network, in which case this fabric will be important, and that's why the IP layer is very important, because for OpenADR, if you don't have IP, it won't work.
The typical AMI network right now, for most, especially fast DR applications, is not fast enough. It's just too much latency, whereas Wi-Sun, having basically IP protocol over this network will speed up things considerably. So it could run over the Wi-Sun AMI network.
So ADR could run over it.
Yeah, there are two dimensions in which they've loosened the boundaries. One is in packet size, which is very important, especially if you're going to have SIM-like commands coming across. And the other one is the bandwidth. What did you say the upper end was?
Well,
800?
Yeah, so what we're defining at the moment goes up to 300 kilobit per second, but 15.4G OFDM will run at 800 kilobit per second. So, and we know there are vendors that have it. We're just waiting for at least two of them to say, come and do some interop testing.
So in the old days, if we had 65 or 70K, we would dance in the streets. Now we're talking an order of magnitude increase. So
what does that do to reliability when you have a packet that size going over network?
Well,
Can you
so
repeat the question?
So the question was, what does that do for reliability? And the answer is, it depends on the problem that you're overcoming. If you're overcoming sort of sensitivity issues, then it reduces the reliability. If you're using, so as Erfan said, we're talking about energy per bit ultimately. So the faster you go, the lower the reliability for a given in this spectrum relate to interference. So you actually improve the interference mitigation because you're on the channel for less time, so the probability of being interfered by another signal is reduced with that.
Assuming there's no congestion there.
Assuming there's no congestion, then it all comes down to whether you're at the limit of sensitivity or not. Yeah. But then if you are and you start dropping frames, then typically you hop through another node. Yeah. So I mean, there are member companies of YSUN that have data available that they share with customers that shows how the routes are built and how packets are transmitted. And you look at San Francisco, downtown San Francisco, across to the East Bay, and it's really interesting.
Yeah. And so a key thing here is, again, protocol and its relevance to a domain. So you want to keep a light footprint across wide area networks, and you can have a bigger footprint in smaller distances where reliability is not as big an issue. When you're going across mountains and stuff like that, keeping your packet size small, having very efficient instructions is the better way to go. And that's why the boundary between OpenADR and SCP, there's been a lot of debate on where that boundary should be. In my opinion, it should be as close to the customer prem as possible. Keep SCP in the customer prem, keep an OpenADR on the outside.
But if you go back to the previous question about, so there was a question about does OpenADR support compression, or like EXI, for example. YSUN Alliance is only looking at the underlying communications technology. So, for example, with IPv6, we're still using 6LoWPAN, but we're using 6LoWPAN because that enables you to get header compression in there and not carry a whole load of redundant information. It also enables you to reduce the frame size and send more smaller frames, which is better for interference.
What's the maximum range of a YSUN radio, and how many frequencies are anticipated that you could hop between?
Okay, so
how many channels?
I think we have something like 96 channels in the 902 to 928, and people are getting ranges of around 5 kilometers. Not necessarily in downtown San Francisco, but if you're, I mean, certainly it is possible to hop across the bay. You can go from downtown to Oakland without a repeater in the middle. So that's quite cool.
So if radios that are on premise would have much shorter ranges, so they're not interfering within a 5-kilometer radius. That's a huge radius.
Yeah. So typically you have power control on them. So like a GSM type signal, you can have power control, so you can reduce the interference and stray signals. And this comes back again to what Rolf was describing earlier: is that these are not even though it might work as plug and play, you don't necessarily get an optimal network out of plug and play. It's actually worth doing commissioning on this sort of stuff, so you can get an idea of, so you can reduce that interference, unnecessary power transmission as well. Okay, how are we doing here? Am I running out of time? Shall I fly?
In the next few minutes.
I will fly then. Okay, so let me talk a little bit about the interoperability testing events. So we have two phases. While we're doing testing and certification program development, our interop events let us do quality assessment and improvement of the profile specification, the test spec, the test equipment and test tools, and also member company product implementations. It's a really good way of coming to maturity. And we have a formal reporting strategy for assessing the status. So the people that attend are expected to complete a whole summary of everything they've done, with whom they've done it, and then that all gets anonymized and we collect statistics from that, which we can then use to improve stuff. And then in a steady state, it's, the interop events are a good opportunity for member companies to check whether they're ready to go for certification and whether they're good for deployment, and we can continually assess the test and certification program, and also check the impact of any profile changes. This is a bit out of date. We've had another interop event since then, but this shows our frequency of interop events. So in October, we were appointed by TEPCO. We had a profile. We didn't have a certification program, and we had monthly interop events that took us through until February, when we had the certification program in place. And we had some very tired and grumpy engineers at the end of that period, but people worked very hard to get it there. But typically, we're holding 4 test events a year. The pictures, not desperately, well, that's pretty good. Lots of engineers sitting around. Let me talk briefly about collaboration. So we basically sign MOUs or liaison agreements with any organizations with whom we might have a common interest. We did so with the ECONEC consortium, and we have a dual logo certification plan. So this is not joint, it's dual. And what this means is that a product developer can take their product to a Wi-Fi Alliance approved test lab, get the comms profile approved there, and that actually means something when they go to the ECONEC consortium. Interestingly, the ECONEC consortium is looking at deploying WISUN certified testbed units to use as the transport layer for doing the ECONEC application certification. There's a picture of a couple of people signing an agreement. Our other collaborations I mentioned Jutta earlier. We have a liaison agreement with OpenADR. So at some point, I would suspect if our joint members would like to do so, we could look at having a interoperability test event of running OpenADR over WISUN technology. Now, WISUN Alliance also recognizes that 15.4G isn't the solution to every problem. We have a liaison agreement with HomePlug, and we expect at some point to look at having hybrid networks and to do some interop testing with hybrid networks. So all of this is heading towards that SGIP TCC goal of a few years ago of end-to-end testing. That's what we're looking at trying to do. Here we go. Some press releases. Certification status, we currently have 19 certified products. By certification is really appropriate for RF silicon vendors who want to prove to our member companies that their chips can do the job, that anybody is allowed to do by certification. And also, as I mentioned, we have approved test equipment. So we have a methodology for approving the test equipment. And there's some happy people with receiving their certification. Future milestones, we're doing a hand profile for ECONEC, which, if you remember, is the piece from the HEMS controller to the end device. 15.4G is one technology used there, PLC is another, Wi-Fi would be another. We'll look at the 15.4G only. The fan, we have the feature complete specification. We're refining that through interop testing. It will be global, suitable for Japan Route A, North and South America, Europe and Asia Pacific. And we expect certified products in Q4 of this year. And then we have the M2M group. This is slightly late, we're expecting working group to form very shortly, but we'll still have a first profile ready by Q4. We've had a number of open houses. First one in Japan, we had 150 people participating. We've done them in Singapore, and we recently had one in Kuala Lumpur at Asia Smart Grid. That's it. Thank you. Thank you for your time. Sorry I overran.
Very good. So if you think out of the box for a minute, no pun intended with all these boxes that are being tested in your alliance, one dimension is microgrid. We didn't talk much about it in this presentation, but when you're dealing with low power, narrow bandwidth mesh with these new possibilities of the larger packet size and the higher bandwidth, microgrids would be an amazing application for the standard as a way of doing SCADA. The other area, because the distances are not that much, the other area which will be very important is commercial buildings as well as industrial controls, because Modbus and OPC and LawnWorks, all of these protocols can be carried on an IP platform. And the lower layers are yours, basically the IP and below. And the semantic layer could be these protocols, which suddenly opens up totally new markets. So I see plenty of potential for this, not just in the traditional utility fans and HEMS.
Oh yeah, definitely.
Great.
Along those same lines, it seems like given the range advantage of Wi-SUN over Wi-Fi, I would expect to see it be applied more on a grid scale as opposed to a home area network scale. I was actually surprised to see that you would use this in a home area network since Wi-Fi is so dominant. Everybody knows how to do it. It works great, and you're kind of coming into a really crowded space, and I don't see why there would be any benefit to that.
Oh.
So the answer, so in Japan and in Europe, 2.4 gig doesn't necessarily cut it without having routing. You can do a star-type network using sub-gigahertz, particularly where you've got the propagation characteristics of thicker walls. Japan chose it because they have a lot of meters in basements. They have multi-story dwellings, and you can get much better propagation. So, but again, it's horses for courses. If there is an installation that already has a Wi-Fi router there and everything's talking, then why put new technology?
So we're going to save additional questions for Phil because Rolf has a hard stop at 3 p.m. Pacific, so we want to make sure that he gets at least a few minutes to talk about IP500. But the number is big, so he must probably go really fast. That's why it's called IP500 as opposed to 50 or 5. So I'm hoping, Rolf, that you're going to live up to the name and go really fast.
I'll try that. Thank you, Erfan. And I apologize. I didn't think that this webinar would go for 2.5 hours. So I'm chairing another call at 3 o'clock, so I have to somehow get my go-to-meeting up and running before I hit the road. On the other hand, I'm actually kind of glad that Phil went first because, it was all smart grid related, fits very well with OpenADR and so on. And now when I jump into actually a different vertical here. Another standard in the 802.15.4 space based on 15.4b or 2006 is IP500. And if you look around the room here, for those that are here in the room, you see, for instance, these exit signs there. You see, of course, smoke detectors and all of these devices here in the ceiling of this room. And really, that's how IP500 originally came about. And there were a lot of manufacturers of these more safety-related items, access control, things like that. They came from other groups, and we're quite happy how it worked there. So you see like Bosch, a lot of German companies here as well, a lot of Europeans in general. And they took a slightly different approach to this. So again, I'm probably not going to be following all the slides here, so I'm kind of condensing that a little bit. So they took the OEMs aside, and took the chip makers out of the equation at this point. So the guys making these smoke detectors, these exit signs, simpler management like door locks, key card systems, things like that, access control, and talk to them what they would like to see. And they wanted to have a reliable network, mesh network, that helps them in particular commercial buildings, of course also residential but commercial obviously has a much greater number of these devices everywhere here. And they want to have something that supports EN, VDS in Europe, UL, and other requirements when it comes to security systems. So security systems for buildings require different type of certifications. There are different standards, EN standards and so on, that cover a lot of the more functional safety-related security requirements. So they looked at all of this and they basically set a standard for themselves. They took 802.15.4, but again, they didn't want to take anything that comes directly from a chip maker. So they created their own requirements for that. They got these requirements blessed by a lot of these organizations, and then started building up upon that. So they created the spec after the 2009 framework, when they had the initial ideas done. Then they went out and found partners like TV Rhineland for testing, like Varta for batteries, and other vendors within their ecosystem to create products and to really create an environment where these sensors in commercial buildings can all talk over one network, essentially. We use 900 megahertz, and like I said, 15.4 2006. And they built IPv6, 6 low pan over the 900 megahertz version of this. QPSK modulation, so they're getting really good speeds about 500, that's where the 500 comes from, 500 kilobits per second in these local networks there. BACnet approached them. BACnet always had trouble with their buildings, so they implemented BACnet in they adopted, I should say, BACnet into this, so they can run BACnet over IP over this network as well. So really, again, it runs TCP, UDP, and the idea you can envision is that it runs very similar to a Wi-Fi network, but for the sensors in the building, exit signs. A lot of companies there make intelligent exit strategy systems, where depending on where fire or emergency is in the building, people are being guided a different way, for instance. So there's a wide variety of applications that are possible here. So I'm going to switch through that quickly. Again, to summarize this a little bit more, performance was critical for these systems in bigger buildings. So they can do 500 kilobits per second. They meet these safety and security regulations for fire safety, smoke detector networks, and so on and so forth. So they fulfill these requirements for commercial buildings very well. So they're in a good position there. All right. I mentioned this already. Sorry, I'm flying through this here. And again, some applications would be, for instance, smoke detection. So you can have a fairly decent reach with the 900 megahertz system. So this is not thought to be like YSUN, a longer reach network. This is going to be a shorter reach, yet slightly better connectivity than a 2.4 gigahertz system in the buildings. And they see a lot of applications popping up using IP500 in Europe there, and of course also other facilities like medical facilities or and so on and so forth. So the development kit is out. It's built by Cornetics, and that's in fact the next step here for the Alliance. Now that they have the specification, they have the two-chip development kit, everything is done. They are looking for chip makers to design their chips exactly according to their specifications. That's what the OEMs are looking for there. But there are already these CNX 100 modules available from Cornetics. So we don't have to go through this. The typical one of the next places for them to be is the security show in Essen, in Germany. Again, a lot of fire alarm systems, emergency exit, as I mentioned, and other sensors in commercial buildings. And they think they will have a good response over there. So again, I flew through this. I left out a lot of it, so feel free to shoot me an email, and we can talk offline some more.
Tell us the significance of the 500 and IP500.
It's the speed. Yeah, 500 kilometers.
And you held on to your commitment, and you went as fast as the speed was.
Yeah. I got 5 minutes to start my next conference.
Okay, very good. Thank you, Rolf. And
shoot me an email. I'm obviously not an expert for that. I can talk all day about OpenADR, but this is a different project here. So if there are questions that I can't answer, I'm happy to connect you with folks that know. All right.
All right. Thank you, Rolf. So there are some comments and questions for Phil Beecher's presentation, so we're going to go back to that. And I'm going to leave this email address just for a moment here while we look at some of those questions. So Ray Hayes says, when should we expect to see Itron meters, Silver Spring network relays, Landis+ gear takeout points, and Oracle head-end MDM interoperating in utility AMI installations? Phil.
That's a very good question, Ray. Another good question from Ray Hayes. I don't know the answer to that. I think the first answer to that is that you will see that happening, whereas 4 years ago it would have been hard to imagine that ever happening. We are reaching. Can you hear me?
Oh, yeah.
Okay.
It's fine. It got better.
Okay, good. So we have interop test events. We've been having fan interop test events. The results of those are kept confidential for the attendees, but there are names on that list that have demonstrated interoperability so far. So I would say we'll have interoperable products from vendors off that list in Q1 of next year, but not necessarily everybody on that list in Q1 of next year. Does that answer the question?
I think so. I think Ray also wants to say, I vote for filling the full interoperability matrix. Takes some work, but well worth it. He's talking about the Human Genome Project for Wi-Fi.
Well, actually, HomePlug does this with their PLC chips. Every time another device is certified, then it adds to the matrix, and the next device has to test with everybody else. However, the number of silicon vendors making HomePlug PLC 1901.2 is a lot smaller than people making 15.4G final products. So
it reminds me of parties back home, where every new guest comes, he has to shake everyone's hand, and the crowd gets bigger and bigger. Okay.
So the test labs love it, because the test time increases and the costs go up. But the last person at the party doesn't like it too much.
Okay, Michael Shea says, would all the skip slides be shared with us? Of course. Next, what Brent Marsh, okay, so what is the transactive energy event that Rolf mentioned? On the, I think on the IP500, was it, or on the OpenADR?
GWAC next week at Folsom. They're doing a transaction.
Okay. Energy. Come closer and say it in the phone.
Yeah, next September 7th and 8th and 9th in Folsom, California, the GWAC, Gridwise Architect Council, is having a transactive energy forum over in California. Ken Wax is hosting it, along with Ed Kazelet.
Yes.
Yeah.
Of TMIX. Yes. Okay. Other questions in the room for Phil online? We will just carry this on for a few more minutes. We're setting an all-time record for Smart Grid Educational Series. This has gone from a 90-minute format to a 150-minute format.
Apologies
But
for talking too much.
what I like is that you're all engaged and you're asking good questions. So it's well worth the time that we're putting into this. Oh, here were some more questions that we didn't get to here. Okay. So first question, Michael Shea says, where would 802.11ah fit in the scope of Wi-Fi?
That's another fantastic question as well. So not necessarily within the scope of Wi-Fi Alliance. So this is a topic for conversation between Wi-Fi Alliance and Wi-Fi Alliance. The corridor conversations have already started. We haven't come to a formal arrangement. I think the key thing is you have two technologies that may be appropriate, there may be an overlap between them, and it's helping ensure that it's explained properly to the end users and the customers as to how you deploy these technologies and what's right for what environment.
Yes. Also, the thing is that, again, about relevance, protocols and relevance. So when you're dealing with large geographic areas, it's very difficult to illuminate them universally. It's much easier to, get things point to an area and then spread it out. So a lot of entities entered this market of creating a hotspot for whole areas like cities or towns, and the business model has not been the best for them. Whereas for utility applications or microgrid or community-based networks, where you come in and there's a certain area in which you need the connectivity, it works much better. So these low-power, narrowband networks, this like field area network kind of thing, people are confused, well, why do we need this when we have Wi-Fi? Well, if you look at the power that you need on a Wi-Fi network to do the functionality that a low power can pull off, why would you want to spend that extra power? Especially if the bandwidth is not required for those simple instructions that need to go. So you have to look at your use case and then build the fabric underneath it, as opposed to just saying, I'm just going to use this protocol for all my applications. So that's where people think there's an overlap until they define a use case. Then they will see from their business requirements, the technical requirements that are distilled, the choice of the protocol becomes obvious.
So the other thing is, I think 802.11ah is still going to be a star technology. I mean, I assume you can run 11s, which is the mesh network, but the meshing there is still between access point to access point, and not to leaf nodes. So
okay.
I think the system topology for 11ah is different from a Wi-Fi 15 4G topology.
Now this mesh is different than that NEMO thing that they talk about in 802.11, right? Where they will send two signals and then they'll reinforce each other on the other side.
This is not NEMO, no.
Okay,
no.
NEMO, sorry. I got confused with the Disney character. NEMO,
No,
I get confused.
NEMO is about getting a lot of data through
exactly.
as quickly as possible.
Right.
So.
There's physics involved there because you're reinforcing the signal when you see that it's part of the same communication on the other end by going two different paths. I remember an access point that did that in the old days. Okay, so the next one is, I think the answer is obvious here. Would Zigbee be compatible and interoperable with 802.15.4G?
So Zigbee traditionally focused on 802.15.4D, 2.4 gigahertz DSSS modulation. So through a bridge or gateway product, yes. Zigbee does have work going on using 15.4G at the moment.
Yeah.
And we do have discussions with them from time to time.
If I recall, in the very old days when there was a theoretical specification for Zigbee, there was one for 860 some megahertz Like there was the 2.4, but then there was a sub-gigahertz spec too.
Yeah, so there was 868.3 and 902 to 928 DSSS.
So would those flavors be compatible with your 802.15.4G?
Well, so Zigbee is another industry alliance that it basically develops on top of 802.15.4 technology.
Correct.
The sub-gigahertz stuff from 2006 spec is not physically compatible with the 15.4G modulation technology. So the answer is no. But Zigbee didn't pursue that particularly vigorously at the time. There were a number of member companies that were interested, but Zigbee focused on 2.4 gig.
I mean, the way I see this question. So the point is being made that the SEP 2.0, is it, or 1.x? Both. 1.x hasn't been specified on the sub-gigahertz for the Zigbee. Okay. But if you take the generic object model of SEP 2.0, then all those issues become moot, because you can run that on IPv6 and you can run that on 6-LoWPAN.
So I think, as far as SEP2 is concerned, the CSEP Alliance is now managing that activity, and my understanding is that that has membership from Zigbee, Wi-Fi, and HOPE1. So you can take SEP2 as an application layer and run it on a multiplicity of transport layers.
I did want to emphasize the importance of the interface between Wi-SUN and the Home Plug Alliance as it comes to electric vehicles, because a lot of the DR signals that are going to go to EVs most probably will run on a power line, because that's the wire that's going to carry the charge also. So having that interface is going to be very important. Other questions? Clint Powell is asking, thanks, Erfan, got it. Okay, Ray has to go. For Rolf, Rolf is gone, but maybe we can answer this. Isn't 15.4 2006 250 kilobits per second? The answer is yes, it is. It's theoretical, though, 250 kilobits per second.
Over the air.
Yeah.
Well, it's real. Yeah.
Is it real?
So
it's not throughput. I mean, real is that the application cannot realize that there's no overhead of the protocol.
Okay.
It's over the air.
Okay, so it's not the throughput. Okay.
no, that's
Peace.
correct.
Because I think of throughput when I think of bandwidth.
Is much less.
Okay. So yes, the answer is yes, 250 kilobits per second. And then from Clint Powell to host, I don't see any IP500 devices on the microchip website. Okay, so we will ask Rolf about that. Other questions from the audience or online for Phil Beecher? Because Rolf Bienert has a call, so he had to go. But if there are questions for him, we will pose it to him later. But for Phil Beecher, we can get your questions answered now. And as I said, if you're registered, and also for all of you, please make sure that either you're registered online or you leave your name and your email address with me so that I can get you these slides. Those who are registered online already, they're automatic. And I know many of you did do a registration. Do you have any parting comments, Phil?
No, just to say thank you very much to everybody for listening to me go on for such a long time. And visit the WhatsApp website and join up if you're interested.
Did you have any pain points to share, like pain points of the Alliance, things that you would like help in? Or, I mean, I know you want to grow your membership, so that's clear. But are there any technical issues or anything that input from the industry would be helpful?
So, well, we have a fairly good membership now, and it's very collaborative.
Okay.
So, all the you experience the 15.4G atmosphere. White Sun is nothing like that.
Wonderful.
Now it is a bunch of product vendors who are trying to develop interoperable product to sell their product. So, and I think from a technical point of view, we've got lots of good contributions, very constructive. It's interesting to get the end user's perspective on requirements. So requirements for testing and certification is always of interest. And we have reached out to the utility companies to get their input on this. So one of the things I didn't mention, so EPRI has joined White Sun Alliance, Duke Energy has recently joined White Sun. We have a number of Japanese utilities that are members of White Sun. So we're trying to get that balance between product vendors and the customers.
Wonderful. Well, thank you, Phil.
Thank you.
And I would just like to share a couple of observations before we call it quits today. One is that it is really important going forward to remove all the barriers to demand response, because demand response has become essentially the new way of doing capacity. Because we are very limited because of the regulatory policies in this country to building a lot of big power plants. And renewable energy comes at certain times and doesn't come at other times. So when it's a small percentage of the overall energy mix, it's not a big deal because there's enough margin from the centralized power plants. But as that equilibrium shifts towards more distributed generation that is intermittent, we really have to make sure that demand response has deep penetration in the society. That cannot happen without interoperable products. I think if between the presentations of Phil Beecher and Rolf, you saw how many touch points there are across the fabric to support demand response. Phil Beecher showed you the lower layers and how that's important, and Rolf showed you the upper layers with the OpenADR protocol and the IP500. So going forward, we have to really think about how we maintain national security and economic stability by making sure that as consumers and as prosumers, we have a good alliance with the government and with the utility industry. And having these standards in place is going to be important. We are going to have another Smart Grid educational series in October, and UL will be hosting that. We had an event in August, but because of schedule conflicts, we were not able to have that. I was traveling, and it was difficult to have that in-person seminar. I will be announcing the next speaker and presentation over the next week or so, and I really want to thank the people here at Thetacom and for this amazing facility of having the camera so that you could see a little bit of the people presenting, and also the hospitality with the lunch and dessert. I'm sorry for those who are online. Yeah, I could swing the camera and show you the goodies in the back of the room. But Gary, thank you so much, and to Mon also for providing us this beautiful facility. And I hope that this will be a relationship that we can continue, and we'd love to keep coming to Milpitas, California. So at this point, I would like to thank everyone, and I'm going to stop the recording and go here, and we'll thank you very much.
Thank you.
And